These are the examples for section 4.5 on the graphs of sine and cosine functions. So example 1 says to find the amplitude and period for the function. So A, we've got y equals -2 sine x. So first we're going to start with amplitude, and for the amplitude we're going to look at the number in front of the sine or the cosine function. We're always going to take the absolute value of that number. So this is going to be the absolute value of -2, which equals 2. So this means that 2 is going to be half the height of the graph. It's going to go up 2, down 2, up 2, down 2. Next, we're going to look at the period. The period is the distance that it takes to do one revolution. And for that, we always do 2 pi divided by the coefficient of x, whatever number is in front of x. And this is a 1, so then 2 pi divided by 1 is 2 pi. So the amplitude of this graph is 2, and the period is 2 pi. Okay, same thing for B. We're going to start with amplitude. Amplitude is the absolute value of the number out front, so the absolute value of 1/2, which will just be 1/2. Then for the period, we're going to do 2 pi divided by the coefficient of x, so that's 2/3. So when you're dividing a fraction by a fraction, remember to flip the denominator and change it to multiplication. So it's going to be 2 pi times 3/2. Those 2's are going to cancel out. So this is going to be equal to 3 pi. So this has an amplitude of 1/2, so it goes up 1/2, down 1/2, up 1/2, down 1/2, and it does that across a distance of 3 pi. Okay, number 2 says to describe the relationship between the two functions. So for A, I've got f of x equals sine x and g of x equals sine of x minus pi. So we're always looking at what's the same between the two functions and what's different. And the only difference in these two functions is the minus pi in parentheses. So this is going to be a horizontal shift in the graph. Pi spaces, since it's a negative, it's actually going to go to the right that many spaces. It's always the opposite sign that you would think in parentheses. So g of x is f of x shifted to the right pi spaces. For B, f of x equals sine of 2x, and g of x equals -3 plus sine of 2x. So they both have sine of 2x in them. The only difference is the -3 out front. That -3 is the d, which represents the vertical distance or the vertical shift in the graph. So this time for vertical, the sign tells us the direction. So this time g of x is f of x shifted down 3 spaces. Okay, number 3 wants us to graph these two functions on the same coordinate plane. So before we can do that, we want to find their period and amplitude for each, and that will help us sketch them out. So f of x is 2 sine x, g of x is 4 sine x. So for f of x, the period is going to be 2 pi divided by 1, the coefficient of x, so that's just 2 pi. And the amplitude is going to be the absolute value of 2 is just 2. Okay, so I'm going to use that information to help me graph. So I'm going to start by graphing. For sine, we always start at 0 unless there's a shift. So we're going to start at 0, we're going to go up the amplitude, back to 0, negative amplitude, and then back to 0. Keep the same pattern every time. So starting at 0, then at the next marker, which is pi over 2, I'm going to go up to 2, which is the amplitude. The next one at pi, we're going to go back to 0. 3 pi over 2, we're going to be at -2, and 2 pi is back to 0. So always follow this pattern for the sine functions. So if I connect the dots, that's going to be the right-hand side of the graph. Now I'm just going to kind of flip that and do the same thing on the other side. So at negative pi over 2, we're actually going to go down to -2. At negative pi, we're going to be back at 0. -3 pi over 2, we're going to be at +2. And -2 pi back to 0. So connect those dots. Make sure on the ends you show that it continues in both directions. So this is f of x, which is 2 sine of x. Now for g of x, we've got 4 sine x. So let's start with the period. So the period again is going to be 2 pi, because that's 2 pi divided by 1, the coefficient of x. The amplitude for this one is going to be the absolute value of 4, which is 4. So the only difference between these two graphs is going to be how far up and down the graphs go. So we're going to start, the points are going to land on the same angle marks, it's just this time they're going to go up to 4 and down to -4. So we're going to start at 0, we're going to go up to 4, back to 0, -4, back to 0. Connect those dots. Okay, now on the other side at -π/2, we're going to go to -4, back to 0, +4, back to 0. Connect the dots and make sure that they continue in both directions. So you can see the difference between these two is a vertical stretch. One is a little bit taller than the other. Okay, number 4 wants us to graph cosine of x over 2. So we start with the period and the amplitude. So for the period, we're going to do 2π divided by the coefficient of x, which is 1/2. X divided by 2 is the same as 1/2 x. So 2π divided by 1/2 is the same as 2π times 2 over 1, which is 4π. So this has a period of 4π. Then we want to know the amplitude. Amplitude is the absolute value of the coefficient, which is a 1. So that's just going to be 1. So this graph is just going to go up to 1, down to -1, and it's going to do its full cycle through 4π. Now because this is a cosine function, cosine starts at +1 at 0 instead of at the origin. So we're going to start up at our next angle, which is going to be pi. We're going to go back to the axis. Our next angle, 2π, we're going to be at -1. At 3π, we're back to 0, 4π, up to +1. So with cosine, we start up, back to the axis, down, axis, and then back up. So connect these with a curve. Actually, we're going to go in the negative direction, then we'll connect them all. So at -π, we're going to be at 0. -2π is -1. -3π is 0. -4π, +1. Okay, connect the dots, draw your arrows to make sure that it goes in both directions. So this graph is showing 2 full cycles. One cycle would be from 0 to π, that's one period, but this is actually showing 2 cycles. Okay, number 5, y equals sine of x minus pi over 4. So we've got a period of 2π divided by the coefficient of x, which is 1, so that's just 2π. The amplitude is going to be the absolute value of the leading coefficient, which will be 1, so that's just 1. And then on this one, notice that it's got a minus pi over 4 in parentheses, so that's going to be a horizontal shift, pi over 4 right, okay? So what we need to do is this graph is still going to have a period from 0 to 2π, but it's going to shift over. So instead of starting at 0, we're going to start at pi over 4. And then we're going to follow the same pattern. So I'm going to start at pi over 4. I'm going to go 2 spaces over and go up to 1. 2 spaces over, back to 0. 2 spaces over, down to -1. And then I've run out of room, so I can't go any further. So now I'm going to go on the negative side. So 2 spaces to the left, I'm at -1. 2 more spaces, back to 0. 2 more, +1. 2 more, 0. Okay, so this is actually continuing the graph in the negative direction. When you connect the dots, you can see that this would be 2 full cycles of the graph. Okay, your homework is on page 328. You're doing 2 through 62, every other even.